Are all bonds the same? I don't know. But after this lab, my students certainly discovered that they are not. How best to carry this out? Well, it has been powerful for me this year to realize how much you can learn from simply dissolving salt. In this experiment, we actually dissolved 7 different salts in water. And my students took some basic temperature measurements while the magnetic stir bar is rotating about in the beaker. A Google Doc handout as well as Google Sheets data are provided in the description below if you'd like to try this out with your students. I'm showing you here 2 different salt solutions, sodium nitrate and sodium hydroxide. The students measured 10 grams of each, obviously using a balance, and then the next step was to transfer their beaker to a hot plate. And the most fun they had was to simply add a stir bar to their various beakers. Again, we did 7 in total. I'm only showing you here 2. So once you've added the stir bar, crank up the stirring wraps, and then the thermometer would actually check how much the temperature is going to either rise or drop. So just picture 7 different lab groups doing 7 different salt solvation reactions, and they're all observing different things. So one side of the classroom is saying, oh my God, the temperature of my salt, it is starting to rise. Oh my gosh, for my salt solution, the temperature is starting to drop, and all the degradations in between. So for sodium nitrate, you can clearly see that the temperature is dropping significantly. For the sodium hydroxide, as you can see here, a little bit more slowly, it's going to start to rise and rise. So these 2 extremes were really powerful. And again, we're thinking here about, are all bonds the same? Now we are ready to actually analyze the data. So what I'm showing you here is the Google Sheets where we have all this data collected. And the data is kind of all over the place. We're seeing the 7 different salts, and we're seeing all kinds of temperature changes, either a drop or a rise. And so the first step that I'm going to do is have students sort this data. So we're going to select and go to the menu, Data, Sort Range, and I'm clicking on Advanced Range Sorting Options. And by clicking on that, we're going to sort by the column that actually gives you the temperature. If I remember correctly, that was column F. We are also going to use data as header row. So that's the top row, which just has the menu named. And we're going to go from the lowest temp to the highest temp. So that would be A to Z. Okay, let's check it out. So now we're nicely seeing the data sorted from negative 15.8 all the way up to 43 degrees. So we're now ready for the step where we're actually going to create a chart. So again, I'm going to select the data, insert, chart. I'm going to pause for a sec because we really only want to have in our chart, for me, I think the most important columns are the name of the salt and the temperature change. So I'm going to click on column A. I'm going to hold my control button and click on column F. So I now have these 2 key important columns highlighted. Now I'm going to click Insert Chart. And when I insert that chart, we're going to see all the different kinds of bars within this graph. So let me zoom out just a little bit so we can see it all. We have a nice x-axis that shows us all the different kinds of salt. We really want to add a y-axis. The y-axis we can now label, going to Customize, Chart and Axis Title, and I'm traveling to Vertical Axis Title, and I'm going to type in temperature change in Celsius. Come on, there we go. So now we have an x-axis labeled, we have a y-axis labeled, but you know, we need a title. And the title could be something like solvation reactions versus temperature always have a hard time spelling temperature change. There we go. So we can obviously select that, center it, make it bold, make it black for that matter, to really pop that out. The next thing that I do like students to do is to make the visual even better. Clearly, the first 1, 2, 3, 4, 5 salt solutions caused a drop in temp, and the last two are a rise. So I'm now selecting, let's try and see if I can select both of these. Well, let's go with the first one. And I really want that color to show the temp rise, so I want that color to be red. I'm going to do the same thing with the second one, and now it really nicely shows you the 7 different salt solutions, which 5 shows you a drop, which 2 show you a rise. And then they can simply copy that chart into their Google Doc, which is their actual lab handout, again, which I've included in the description below. Now that we've completed the data analysis in Google Sheets, I do want to make you aware of a different video that I did a little while ago that is titled How to Evaluate PhET Gas Lab Data using Google Sheets. So I also go through some data, this time collected through the PhET simulation, but very similarly analyzed using Google Sheets. The next step is basically a discussion board that I share with my students. This shows you the result of all the different lab activities that we've been doing as part of this storyline that was inspired by iHub inquiry. And this storyline is all centered around why does the temperature drop or increase when chemicals are mixed. And since this video is all related to are all bonds considered to be the same, we have to think about how we're going to model this. So this particular question, how can we best model a reaction that results in a temperature decrease, was very much focused around one of the 7 salts, namely potassium chloride. So this question may actually promote students to pull up their Google Keep notes, which is another video that I did recently, how to best take notes using Google Keep. So this very central question, how can we model one of these solvation reactions, can then be answered using Google Keep. Here I'm showing you how I chose to model the solvation of, in particular, potassium chloride in water. So you're seeing here the crystal lattice of potassium chloride, the water molecules, and with the result of some added heat, because the temperature is dropping as a result of this solvation reaction, the ionic bonds between the potassium and chloride ions are broken, and new bonds are formed between the water molecules and either the chloride or potassium ions, creating these solvation shells. And because the temperature is significantly dropping, I'm showing you here the ice emoji. So how can students come up with a model similar to this one? Well, I show them these 2 helpful GIF animations after their actual salt solvation temperature data collection. And hopefully with the help of these 2 GIF animations, it inspires them to come up with a model like this. And then, of course, the idea behind this, are all bonds the same? Okay, maybe the reason that the potassium chloride solvation caused a temperature drop, similar to the sodium nitrate solvation video that I showed you earlier, is because very strong ionic bonds are being broken and weaker ion dipole forces are formed between the ions and the water molecules. So I hope you took something away from this video. Stay tuned for my next video that involves storyline teaching, which includes this actual experiment. Bedankt voor het kijken en tot ziens. Thank you for watching and see you in my next video.